Thank you. Yeah, so I would like to talk to you about something that developers don't care about. Last year at KubeCon in Seattle, I overheard this quote: "Developers don't care about RPC frameworks, and yet you're all here." Well, of course, we're infrastructure developers, so we have to care. And also, it's always interesting to talk about the nitty-gritty details of technology. So, what also happens is that those kind of fundamental things, they kind of leak out and the abstraction breaks. So we do have to care in the end. So I would like to talk about that a bit. My name is Matthias, and I work at Spotify. I work as an engineering manager in the infrastructure group. And in that group, we try to migrate the organization from something else to gRPC. As a manager by trade and engineer by heart, I love to work in the intersection between technology and leadership. So in that talk, I'll talk about those two things. Because it's not only technically challenging to move everything over to gRPC, it's also a big cultural change that has to happen, and that's where leadership comes in. Yeah, so why are we adopting gRPC at Spotify? There's really, the first half of the talk I'm going to talk about why exactly we're doing that, and then the second one about how we're going about it. So the why really has two parts. Why do we need to change from what we have today, and why gRPC? So why are we changing? Why do we need to change whatever we have today? So today, a little bit about our infrastructure. We at Spotify, we serve quite a lot of people wanting to listen to music or audio. And we have a lot of services that interact with each other in the back end. At the time I wrote those slides, there are about 2,500 services interacting with each other. We do handle a lot of requests coming into our ingress, and we are a lot of developers working on it, right? The backend is mostly written in Java and Python, and for intercommunication between the services, we actually have our own protocol. It's called Hermes. It's actually not that Hermes. I thought it was, but it's not Futurama's Hermes. It's a Greek god, Hermes, and it's named after the Greek god that is the emissary and messenger of gods. It's also, funnily enough, Hermes is also the Greek god for the divine trickster. And where we are right now at Spotify with Hermes, our own homegrown protocol and technology, we feel a little bit tricked. A lot of our own kind of homegrown solutions are actually named after Greek gods. So you might have heard about us talking about Helios, our container orchestration system, about Apollo, our service framework, and so on. But we're not going to talk about that. Hermes was started in 2012, was initially based on CRMQ. The framing was based on CRMQ. The payload is either JSON or protobuf. And it's actually not an RPC framework. It's just a protocol. So maybe it's easier to compare to it with HTTP. And the good thing with Hermes is it works. And we've been using Hermes throughout our backend since then. And I hope many of you use Spotify and you're able to listen to music. So that's a testament to that Hermes actually works. So why do we need to change? The problem is not Hermes in itself, the technology. The problem is that the fact that it's our own thing that nobody else knows about slows us down in multiple ways. First of all, so at Spotify, we constantly hire new people. If you join Spotify, you need to learn about Hermes. We can't assume that people know about Hermes joining Spotify. Well, could they? It's also, we shouldn't be in the business of creating protocols and as something as fundamental as an RPC kind of technology at a company like Spotify. That's a reason why we moved to the cloud, because we don't want to build data centers. And that's likewise with protocols. forces us to write a lot of boilerplate and kind of repetitive code. And there's another aspect, and that's the Hermes ecosystem. The Hermes ecosystem doesn't exist. How could it, right? So you want to use a load balancer? Sorry, doesn't exist. Do you use Nginx? Nope. The common denominator for everything is TCP, and that doesn't get you that far, especially now that we start talking about service meshes and things like that. The same is also with tooling. So you want to debug your API? Well, you have to first write the debug tools to do that. So we have a whole bunch of things that are specific to Hermes. We have, instead of curl, we have jcurl. With jhurl, I mean hurl for the H for Hermes. And that slows you down, and it feels like, why do we have to deal with this? So Hermes as a protocol works, but nothing exists around it, and that's in the end why we need to move. Okay, in overall, that's like our shift from our own solutions, homegrown things, into adopting free and open source software. And if you want to know more about that, there was going to be a talk about more of that today by Jim in the afternoon at the KubeCon. And also there's going to be a talk tomorrow about a little bit more about Hermes and why you move to the gRPC by Austin and Dave tomorrow. Both of them, all of them from Spotify, of course. Okay, so now we know why we need to move. Why gRPC? There's a lot of factors or pull factors that make us want to use gRPC, right? It's open. That's already better than what we have now. It's open source. It's performant. It's based on HTTP2, so there's a lot of standards that we can rely on. It's backed by CNCF, which gives us some kind of confidence that it's going to stick around for a while. Also, it's used by a lot of heavyweights in the industry already. That's also a good testament. It's strongly typed, which is nice. And there's a slew of other features that really make us want to use gRPC. I would like to talk about three feature areas that really make a good case, that excite us about gRPC and that convinced us to go all in. The first one is about the protobuf definition files. I mean, if you've worked with gRPC, the proto file itself is kind of the holy grail. That's where you define your API as one source. You define your API and also your message kind of format. And from that, you can generate code in multiple different languages. So I think at the time of writing, there's a lot of different languages supported by gRPC core. It also gives you kind of this single point of, this single source of truth for your API and your service, right? That's the only thing you really have to share with others in order for them to know exactly how to call your service and what to expect back. We didn't have that before, and many of you, previously I worked in different companies who use HTTP REST. That doesn't really exist either, right? You have to write a lot of JSON boilerplate and deserialization and serialization code, and it always breaks. You have to deal, it's kind of a constant pain. Sure, there's schemas for those JSON payloads, but it's not the same. Few things we learned once we started adopting gRPC is, okay, how do we handle those proto files? If given that they are those central source of truth, what do we do with them? The first challenge we had is kind of convince people that they should embrace those proto definition files. Because we were so used into kind of distributing client chars, client implementation for our services to different consumers, or also just considering our API as kind of a wire protocol. So we constantly have to convince people that, wait, the proto file, that's your first-class citizen, and from there, everything can be generated. So initially we went into we had that work planned out. We would basically write our own schema registry, and we would generate jar files for you and Python, like client libraries and everything automatically. But in the end, we realized nobody else is doing it, so maybe we shouldn't either. Otherwise, we're just going to be in a Spotify Hermes land, which is not much better than Hermes. Once you have that proto file, you want to share it. We don't have monorepos. We don't have a monorepo like others do. So what do you do with Proto files? I think the best approach for now that we have, and a lot of other people do, is we have a shared repository where every service owners puts their Proto file, and from there you pull the files that you need to properly generate the client code that you need to call that service. And on top of that repo, you can write tooling, right? So we have a tool that helps you download the Proto files and dependencies. Also, this is also the place where you can enforce guidelines on how you write Proto files. So in our case, if you want to submit your Proto file for your new Shiny service, you create a pull request, and kind of the CI pipeline does linting and additional checks before it actually can be merged. So that's where you can enforce kind of central policies around API design. Actually, a quick shout out, Uber has a nice tool to handle all Proto files. It's called the Proto tool that we heavily rely on. And we have our own tool it's called Proto Man, that we are looking into if we should just merge our stuff into Proto tool. But that's, and we do that in the open, so that's a change. Cool. And then the third thing that we learned is versioning. Just don't do it. As in, of course you're going to have versions, but don't try to version control. Don't try to kind of distribute different Proto files with different versions in their file name or anything like that, or in your client implementation. Just rely on the protobuf being backwards compatible. If you need to do breaking changes, you create a new package, a Proto package. So the example here, let's say we have a playlist service, the explosive service with a V1 version, that's the major version. If they need to do breaking changes, they'll just introduce a new version, V2. And if you're not comfortable with actually publishing it and kind of setting that version strictly, call it beta 1 and follow that pattern, which many others do as well. Okay. So, a few features another feature I would like to talk about is around resiliency, and gRPC has a really nice features there, different patterns that you can enforce. So the first one is retries. In Hermes, for instance, we don't have automatic retries. You don't have that in the general HTTP client libraries either. In the world of gRPC, you can do retries in interceptors. Interceptors kind of think middleware. And you can kind of just configure how your client should be behaving if the server is not responding. And you can do that just through configuration, and it's very transparent to the application. There is actually a proposal ongoing to kind of get that work into the gRPC core. And one of those aspects in the proposal is hedging, which is an advanced way of retries. So hedging means it's also referred to, you might, backup requests is what's called in the Cassandra land, or people also refer to as speculative retries. So the idea is you send the first request, and after a certain delay, if you don't get a response, you set the second request, and after the delay, you set the third request, basically fanning out your requests to all the backends until you get some response. As soon as you get a response, everything is canceled. Every outstanding RPC is canceled. So this helps you to kind of cut the tail latency drastically in certain cases. The problem, the downside is, of course, that you're going to spend more resources on RPC, and that's really a great way to kind of create cascading failures. And that's where what you end up is kind of a thundering herd kind of situation, right? Where everybody hammers the same backend that's already down, and yeah, it's really hard to get out of it. So to prevent those cascading failures, gRPC has other features that help you. Talked about two things. One of them is called retry throttling and pushback. They're also part of the same proposal. So retry throttling basically means you have a bucket of retries that you can use, and if they're used up, you can't use anymore. So the hedging, for instance, won't issue more RPCs if you already used up your retry bucket quota. Pushback is on the server side, so the server can actually signal to clients to like, wait, hold on, send me a request in a set amount of time again, and try it then again. So it's kind of a way to create, to propagate, I forgot about the term. Anyway, those are good 2 ways to kind of prevent cascading failures. Okay. A second thing that we like about in gRPC, and is deadlines. So instead of setting timeouts manually, you can define a deadline on a request, and the request will be automatically canceled once the deadline runs out. So an example, we have an ingress service calling out to a metadata kind of front-end proxy, and that one calls out to a store. And in the reach request, we can set a deadline. And throughout the call chain, you're probably going to have tighter deadlines the further you go into the back end. And if something in the very back, in the storage, for instance, fails or it takes too long time, we can cancel the whole chain. And since that's part of the gRPC core, we don't need to build that in all our clients everywhere, and that slims down the boilerplate. And another advantage is that since we are in Google Cloud, so since many of the managed solutions in Google, for instance, and other providers as well use gRPC, we can actually use the same kind of way to call out into GCP. Let's say we connect to Bigtable. So we can use deadlines there as well and can enforce it the same way. Also, we're looking into how we can extend that the other way into the edge. So we're looking at how, if we should use gRPC in the mobile client, for instance, and that will give us a lot of benefits, of course, because it's a common RPC. In terms of deadlines, we could actually do deadlines through the whole chain. There's a lot of work going on in there. It's also in gRPC web world. That's not something I'm going to talk about more about, but if you're interested, look up gRPC web. It's a very interesting project. Okay, another thing I would like to talk quickly about is load balancing and routing, where gRPC brings a lot of features to it. Traditionally, you will have server-side load balancing. You have a proxy, and that all the requests go through, and the proxy, the server, distributes traffic through the back end. The problem with that, well, it's very simple. The advantage is the clients you don't have to care about load balancing at all. The problem is you get a latency hit because you have an extra hop. That might be a problem, maybe not. On the client side, we don't have any proxies. You have kind of thick clients that do all the load balancing logic in the client. The advantage is you don't have any extra hop. The disadvantage is you have a lot of complex clients. Remember, we use Hermes, so there is no load balancer for Hermes. So everything we do at Spotify is client-side load balancing today with Hermes. And we actually have a quite sophisticated policy. We use expected latency selectors, which is not today available in gRPC, but it gives us pretty good load balancing across the back end, and we don't have this extra hop everywhere. Now, gRPC introduces another kind of load balancing. It's called the Lookaside load balancing. It's fairly new. The idea isn't that new, but I haven't seen many implementations of it yet. But the idea is here that you get the benefit of, you basically do client-side load balancing, but the logic of load balancing in the client, you extract that into a central load balancer. That's not part of the data plane. So you're not going to have the extra hop. The load balancer sits to the side. I think I have an image. Yes. It sits to the side and basically just feeds the client with updated lists of healthy backends, upstreams. It also, at the same time, of course, monitors the backend and sees which services and endpoints are healthy or not. That's also the perfect place where you could introduce advanced routing or rollout strategies. And if you squint hard enough a bit and consider that this is all just we extract logic from the client, from the data plane into a central place, it suddenly looks very much like a service mesh. Because what the Lookaside load balancer really is just a control plane for the gRPC clients. So there is currently very early work ongoing on actually supporting the XDS routing API from Envoy in gRPC. So you could actually, in the future sometime, maybe use a control plane like Istio to control your gRPC mesh. So you will actually have a mesh that's proxyless and can do at least a subset of what a full-blown proxied word service mesh could do for you. So that's, I think, is very exciting. Nothing that's available today, and we don't use it currently, but I think that's something that we are definitely looking into if it could help us. Okay. There's one more reason why gRPC is great. gRPC has by far the best mascot. The mascot's name is Pancakes, for those who haven't heard about it. And Pancakes because gRPC is an acronym for Golden Retriever Pancakes. And I think if you have that kind of mascot, you don't need much more reason to adopt gRPC. There's more versions of the same mascot logo to Proto and serve. Proto is the Proto compiler. I love it. And thanks to a colleague of mine and work, actually, and help from Google, we have our own Spotify Pancakes logo. So if you would see, that's what I have on the one single sticker I have on my laptop. We have a limited amount of stickers, so if you're interested in that sticker, come talk to me afterwards. Cool. How are we going about it? How do we migrate to gRPC? Because something as fundamental as changing a protocol is a lot of work, right? And we have to consider that everybody at Spotify, all the developers, they have a lot of important things to do, right? They need to kind of deliver value to the customer. If you would be, I hope many of you are customers of Spotify, you shouldn't care that we use gRPC or not. But yet, internally, we feel like we need to do that change. So how do we go about that? Because at Spotify, or maybe across the industry, nobody likes migrations. Right now, we're in the middle of another big migration that my colleague David talked about this morning at Keynote. We migrate everything to Kubernetes. Well, the first thing is we have to embrace the fact that this is a journey, right? This is going to take time. And what we're really doing is we're not necessarily moving just to gRPC. We just move to, So right now we are at 10% migration. We have 10% of our services use gRPC. A half a year ago, we were around a little bit more than 0, so we already made some headway. And what we really want to achieve, the destination, is not just gRPC. We want to get rid of Hermes, because that's one of the big points. But we also really like to encourage people to use gRPC because there's a lot of benefits to it. So, yes, how do we do that? And in order to talk a little bit about how we get the teams to that migration, because we can't force anyone at Spotify to do those things. We kind of pride ourselves and say that we have autonomous teams. So how do we get autonomous teams to kind of want to migrate to gRPC? How do we get them to join the journey? Before, I think I need to talk a little bit about what that entails, because a big migration like that is a big kind of a change, a technical change, but also cultural and organizational change. And change is hard. Change is hard because it threatens what you find is familiar, and it kind of challenges what you're just already had maybe planned, and that change kind of breaks your expectations. And familiar things feel nice and comfortable, right? So how do we build that momentum to move in the right direction? And how do we convince people to move or migrate on their own free will? Unfortunately, we're not Jedis. We can't use mind tricks. So we employ 3 different strategies. So the first one I would like to talk about is I will need to first dive a little bit in what it means to have autonomous teams. First of all, you kind of need a culture of trust in order to have autonomous teams. We trust engineers to do the right thing. We empower them, and giving them access, let's say, to the production environment, and telling them by that we know that you will act in the best interest of the company, empowers them to do the right choice, right? So what we need to do, we don't just tell them, use gRPC, we have to tell them, well, we have to explain to them why this makes sense. And even if something goes wrong, we don't want to blame anyone. We have to kind of see that as a learning opportunity. So the first thing when you talk about autonomous teams is autonomy is not freedom, but it's very often perceived like that. The idea is not that everybody can do whatever they want. The idea is that you align around your autonomy. And I think that diagram shows that very nicely. If you look at autonomy on the horizontal and alignment on the vertical, what you want to end up in the corner to the top right, where we have high alignment and high autonomy. If you just have autonomous teams without alignment, everybody does whatever they want, and we don't get anywhere. If we have high alignment but no autonomy, people just do what they're told top down, which is not very empowering and it's hard to scale. And well, if we have low autonomy and low alignment, I don't know what that looks like. So what we really need is aligned autonomy. And how do we achieve alignment? We do it in multiple ways. One of those is that we make, we have, in order to get alignment around tech, we have something what we call the golden stack, the golden path at Spotify. Basically, the golden path is like a document that helps you, that tells you if you follow these kind of practices and you use those technologies, things will be laid out for you. It's the path of least resistance. It all points, and now that's a screenshot of our developer portal internal, where the different disciplines have their own golden path. And it's if you see, you can think of it as the blessed stack, but you're not forced to walk the golden path. If you don't, though, it's probably not going to be as easy as it could be. And hopefully somebody will hold you accountable that why are you not using the golden path if it would speed you up X times. So what we really do is this: we make the right choice to be the easy, natural, obvious choice for people to take. So the first thing we did, or we're doing right now, is adding gRPC to the golden path and removing Hermes from it. So that this is a clear signal to everyone that from now on, if you use gRPC, we will do everything in our power to make it as easy as possible for you. If you're not in the golden path, you might need to do some extra work. So that's one way. Second thing is we need carrots, right? We need incentives for people to want to switch. Carrots can be things like we address pain points, or it can be features that they're looking forward to, or it can just be overall improved performance, or because they are attending KubeCon and CloudNativeCon and think gRPC is cool. So this is really an exercise of gamification. And again, if you remember Hermes, there is no ecosystem. So pretty much everything out there is a good incentive to switch. So, and in a case of emergency, if you feel like you're not getting anywhere and you have this long tail of migration and we just end up with yet another protocol, which you definitely want to avoid, we want to have kind of finalized the migration in the end, you have the counterpart to the carrot, which is the stick. The stick, of course, we haven't used that much, and we haven't actually used. It couldn't look like you set arbitrary deadlines. You say, okay, Hermes will be end of life by, I don't know, December 2020 or June 2019, to kind of force people to migrate. We really don't want to do that, but I mean, it's one tool that we have in case we have to. It's really, if the migration takes long enough, you kind of force it. So right now, we are just starting our journey. We've did a lot of pre-work to kind of get off the ground. We hope now that the flight is going to be smooth sailing, and we hope it's not going to look like that once we land. And we hope that most of our developers didn't have to care that much about gRPC, just that they have a new RPC in general. So I would like to change this, that developers don't care about RPC technologies, to developers that don't have to care about RPC technologies. They can, because many do, but it should really be something that you don't have to care. Thank you.